All right, guys, are there any questions over the last homework assignment? All right, guys, let's put the computers away and headphones out. Headphones away. All right, guys, so what we're talking about today is simplifying radicals and multiplying rational expressions. So we're simplifying rational expressions, and we're going to talk about multiplying. We're going to finish with multiplying today, and we will talk about it tomorrow as well. A rational expression is a fraction whose numerator and denominator are non-zero polynomial functions. And what that means is that we're going to have a fraction with variables in the numerator and the denominator. And the denominator cannot be 0. So the bottom of the fraction cannot be 0. And we're going to consider it simplified in simplified form if there are no common factors on top and bottom. If there are no common factors on top and bottom, then it is simplified. And kind of when we look at this here, we can look at it in one of two forms, like the first one here where we have AC over BC. Since they both have a common factor of C, we can factor it out, we can simplify it out. And now it's factored, or it's in simplest form because there is no common factor on top or bottom. We can look at this with numbers, and we've done this before, 15 over 65. Well, both of them have a common factor of 5 that can be reduced out, divided out, which would leave us with 3 over 13. We can also do this with polynomial expressions, because if we look at this one here, they do have a common factor of x plus 3 on top and bottom, which can be simplified out, leaving us with 4 over x plus 3. Because once we have everything simplified out, it is considered in simplest form, and it's actually easier to work with. And especially when we get solving, if we have them in simplest form, they're going to be easier to work with and easier to solve. Now the first one here we have is 4 over x times x plus 2. And we want to make sure that it is in simplest form. And to do that, we need to make sure there's nothing in common on top or bottom of this rational expression. So what is in common on top and bottom? Because we do have a 4 and 2 on top and bottom, but unfortunately the 2 is connected with the x plus 2. That's going to be one whole term. So we can't just simplify the 4 and 2 because the 2 is stuck with the x. So is there anything in common on top and bottom? No, this one here is actually just, it's already simplified. There's nothing we can do to it. Putting that one at the start is a little misleading, but I do want to point out the fact that we can't just simplify this 2 and 4 because there's a common factor of 2. That 2 is stuck with the x. Anytime we have addition and subtraction, they are stuck together. They are one term. So we have to treat the x plus 2 as a single term. We can't just simplify the 4 and 2. So this is as simplified as it gets. Let's look at this one here. Is there anything in common on top and bottom? X plus 1. So what we can think of this as is kind of having x plus 1 over x plus 1 times our 2 over x plus 3. Because whenever we multiply fractions, we multiply straight across. So we can break these back up easily. And really what that leaves us with is this here. Well, x plus 1 divided by x plus 1 will simplify to 1, because anything divided by itself is 1, so that simplifies out. Really just leaving us with 2 over x plus 3. And that is in simplest form, or simplified down. Any questions on this here? All right. Now, to be able to simplify ones like this here, well, I kind of already gave it to you. What we're going to do is we have to factor these. Because whenever we give in these polynomial expressions on top and bottom, we have to factor them down to be able to find the like terms, find out what's in common. Because again, whenever we have these individual terms, the x squared, 4x, and 12, with the addition and subtraction or subtraction signs between them, we have to consider this as one whole expression and this one whole expression. So we can't just cancel out the x squareds or simplify the 4x or 4 and 12. We have to factor it down to be able to find the like terms. Which one would we find easier to factor first? The x squared minus 4, because that is a difference of perfect squares. And actually would factor to what? X minus and x plus 2. The difference of perfect squares is our a squared minus b squared is equal to a plus b times a minus b, which in this case would be x minus 2 and x plus 2. Now we do need to factor the numerator, the x squared minus 4x minus 12. Since the 12 is negative, our signs are going to be negative and positive. Now the factors of x squared are x and x. Now we do need to find the factors of 12. Well, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Which one of these sets of factors do we want to try first? So why would we want to try 2 and 6? So it would be to get negative 4. Now for this to simplify, we need something in common on top and bottom, yes? The 2 on bottom we have are x minus 2 and x plus 2, yes? So if I want something to simplify, I need one of the ones on top to be either x plus 2 or x minus 2, yes? Out of all the factors of 12, the only one where I can get a 2 in one of those to match up with the bottom is if the factors of 12 are 2 and 6. So, and that's something that we can do for the rest of this chapter. And when we factor them, factor the ones that you find easiest, and then we can use it as a roadmap to find the others. So we're going to use 2 and 6. Now we can set 2 as positive and 6 as negative. And if we check this, just to make sure we got this right, x times negative 6 would be negative 6x. 2 times x would be plus 2x, which would give us a negative 4x, which we wanted. Yes? So do we have something in common on top and bottom? Well, the x plus 2 and x plus 2, which would leave us with what? 6 over, and that there's the final answer. Because we can't reduce the 6 and 2 because the 6 is stuck with the x, and the 2 is stuck with the x. It's x as well. Any questions on this here? All right. There is one other thing I do want to look at before we move on, and it is restrictions with x. Because with any of these here, the denominator cannot be a certain number. What can't the bottom of this fraction be? 0. We can't have 0 on the bottom of a fraction. So any value of x that would make the denominator 0, we have to restrict from it. Well, what value of x is going to make x minus 2 0? Yeah, positive 2. Because 2 minus 2 is 0, yes? So x cannot be 2. Well, what would make x plus 2 equal 0? So x cannot be 2 or negative 2. And that would be the restrictions for it, because any number that would make the denominator 0 cannot be included. Any questions on this here? All right, let's look at the next one. And again, for this here, we need to factor the numerator and the denominator. So when we factor the numerator, or factor the denominator first, which one do you all want to do? Which one seems easier to factor? The denominator, because the denominator, again, is a difference of perfect squares, yes? So this would be x plus and x minus 3. Because difference of perfect squares for this one here is x plus 3, x minus 3. They're almost the exact same, but the sign in the middle is different. Now let's factor the numerator. X squared minus x minus 12. Since the third term is negative, our signs are going to be positive and negative. Now we do need to find the factors of x squared, which would be x and x. Now we need to look at the factors of 12. 1 and 12, 2 and 6, 3 and 4. Which one would we want to use? 3 and 4. Which one would we want to be positive? 3, 4. And if we check this, x times negative 4 would be negative 4x. 3 times x would be plus 3x, which would give us a negative 1x, or negative x, which is the middle term that we wanted. So these are the correct factors. Do we have anything in common on top and bottom? The x plus 3 and x plus 3, and we can cancel those out, which would leave us with x minus 4 over x minus 3. And that would be simplified. Now, I didn't ask for us to find the restrictions, but if we did, well, we know that x cannot be. It can't be positive 3, because if it's positive 3, the x minus 3 would be 0. And it can't be negative 3, because that would make x plus 3 0. Questions on this here? All right. If you're good with that there, we'll look at the next one. X plus 4 over x squared minus 16. Can we factor x plus 4? No, because if we look at the degree of the numerator, it's 1, because x is the biggest variable we have, and there's not a greatest common factor between x and 4, so there's nothing we can do with it, because it's as simplified as it gets. But the denominator, we can, because again, it's a difference of perfect squares. And this here would factor 2, x plus 4, and x minus 4. And what's the greatest common factor on top and bottom? X plus 4 and x plus 4. And if we factor that out, we have x minus 4 left on bottom. And what's left on top? Nothing, so we would put, because whenever everything factors out completely, we're left with 1. Because it will never be 0. The only way that any two things can cancel out and become 0 is if we're adding a positive and negative or subtracting two positives. Addition and subtraction is the only way we can end up with 0. Whenever we're simplifying things out or dividing two things out of the top and bottom, it's going to simplify to 1 if everything else is removed. And well, our restrictions on this here would just be our positive or negative form. That'd be it. Any other questions on this here? All right. We're going to look at one more of these here, and this time, unfortunately, the numerator and denominator, neither one of them is a perfect square, unlike pretty much all the ones we've had thus far. I'm going to have to factor both of them eventually, but which one do y'all want to factor first, the numerator or denominator? Denominator, so we have x squared minus x minus 6. Since our third term is negative, it means the signs are opposite. One's going to be positive and one's going to be negative. Now we look at the factors of x squared and 6. Well, the factors of x squared are x and x. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want? 2 and 3, and we would want the 3 to be negative. And if we did go through and check this here, it would work out that the middle term would be negative x. So these are the correct factors. Now let's look at the numerator. X squared minus 2x minus 3. Since the 3 is negative, our signs would be opposite. One's positive and one is negative. Now the factors of x squared would be x and x. And the factors of 3 are 1 and 3. Which one would be positive and which one would be negative? Well, the 1 would be positive and the 3 would be negative. And the denominator kind of gave us a hint, because if we want something to cancel out, we need the 3 to be negative. Now, if we had an x plus 1 or x minus 1 at the bottom, we might try that. But this is the correct setup, because if we have it this way here, well, what do we have in common on top and bottom? X minus 3, that will cancel. And I would always make sure and check, make sure that is the correct factorization, and this is, because this here would give us a negative 2x on top. And if we simplify this here, we're left with x plus 1 over x plus 2. And this here would be the correct answer. Any questions on this here? All right. Let's look at the next part, multiplication, multiplying these two together. Caleb, pay attention. So, whenever we multiply two polynomials together, we're multiplying straight across. We're going to multiply the numerators with the numerators, denominators with the denominators, and then simplify where we can. Now, when we have monomial terms, one term on top and bottom, there's really a lot of different ways we can look at this and simplify it down. Because we can simplify it down at the beginning or midway through or at the end. Now, the first one we look at here, we're going to go on and just simplify it at the end. We'll do all the multiplication and then simplify there. Because if we look at these two here, we're going to multiply straight across. We'll multiply the numbers with the numbers and like terms with each other. So if we look at this here, on top we have 8 and 7, and we'll be multiplying those together. Then we'll be multiplying the x to the third and x to the fourth together, because we'll multiply the like bases. And then we'll also have our y times y to the third. And that would be taking care of the numerator. We also have to do the same thing with the denominator, which would be our 2 times 4. Well, we only have one x. And we have our y squared and y. Now, at this point here, we can go on and multiply the like terms together. We can do 8 times 7, which is going to be 56. 2 times 4 would give us 8. On top, we have x to the third times x to the fourth. Whenever we're multiplying like bases, we add the exponents. So 3 plus 4 would give us 7. And y times y to the third, 1 plus 3 is 4. On bottom, we would have our x, and y squared times y would be y to the third. Now, at this point here, we can go on and simplify. The calculators will simplify 56 over 8. It won't do anything with the variables, but it will do the numbers. And 56 divided by 8 is 7 over 1, or just 7. And it would go on top of the fraction. Now, x to the 7th divided by x, whenever we divide like bases, we subtract the exponents. Well, we'd have 7 minus 1, which is 6. So we would have x to the 6. And lastly, y to the 4th divided by y to the 3rd would leave us with 1y. Well, since the only thing left in the bottom of the fraction is 1, I just circle it or include it in my circle as part of the correct answer. I always put the division bar or fraction bar in there just in case we do have something on top and bottom. And if we don't, I just include it as part of my circle saying I got the answer. Because here it worked out everything was in the numerator. We didn't have anything left in the denominator besides 1. Any questions on this here? Let's look at this next one. Now for our numbers, because we can go on and multiply the tops together and bottoms together, and that's just fine. Because on top we would have 6 times 9. And we would have x squared times x to the 5th and y times y squared. On bottom, we're going to have 3 times 2 times x times y cubed times y squared. And I will go through the same process we did on the previous one, but there are other ways that we could actually simplify this. One of them is just actually simplifying at this point here. We didn't have to combine everything together to begin with. Because looking at bottom, what is 3 times 2? 6. Well, we have a 6 on top, don't we? So really this 6, and that would simplify out, wouldn't it? We could also say that this x here would simplify out with one of those there. On top here, I have 3 y's. I have a y cubed here. And all that would cancel. Yes? And let's see what's left. On top, I'm left with a 9. X to the 1st times x to the 5th is x to the 6th. And that's everything on top. On bottom, I'm left with y squared. And that's our answer. So that's another way that we can do this. If you don't feel comfortable with that, that's perfectly fine. Because we can still look at this here and say 9 times 6 is going to be, not 36, 54. Nope. X squared times x to the fifth is going to be x to the seventh, because we have 7 of them. Y times y squared would be y to the third. 3 times 2 would give us 6x. Y cubed times y squared would be y to the fifth. And now we can simplify just like we just did, because we can do 54 divided by 6, which would end up giving us 9 over 1. X to the 7th over x, well, 7 minus 1 would be x to the 6th. And now we have y to the 3rd over y to the 5th. Well, 5 minus 3, or 3 minus 5 would be a negative. So anytime we subtract variables, or subtract the exponents for variables, it's going to end up wherever it's bigger. Because 5 minus 3 is 2, but it's bigger on bottom, so it stays on the bottom of the fraction. Because if we did the straight subtraction, it would give us negative 2. So why do the negative 2 on top? But if we have a negative exponent, we can move it from the numerator to denominator to make it positive. But this here is our answer. Any questions on this here? With crossing it out? Because you don't have to do that one here. If you like this better, stick with this here. Oh, I got squared? Yep, that'll make a difference. Thank you. So it should be y to the 4th here, which would just give us y. Yeah. That's probably the confusion, yes? Yeah. Any other questions besides that extra y I decided to add in there for absolutely no reason? We'll look at one last one. And really, the way that you go about simplifying this is all up to you on what you find easiest for multiplying and simplifying these one terms on top and bottom. And really, if we were going to do this, we could go through and cancel out and simplify out at this point here. Or we can just go on and multiply together and say on top 3 times 6 is 18. X to the 5th times x would be x to the 6th. Y squared times y squared would be y to the 4th. On bottom, 8 times 9 is 72. X times x to the 3rd would be x to the 4th. And y times y is y squared. Now we can simplify from here. And the first thing we'll simplify is our numbers, 18 over 72. And 18 over 72 would reduce to 4. X to the 6th over x to the 4th. Well, 6 minus 4 is 2. And since it's bigger on top, the variable will stay on top. Y to the 4th over y squared, well, 4 minus 2 is 2. And since it's bigger on top, it will stay on top. And that's it. So there's many different ways we can go about simplifying these here and getting to the answer. Because if I really wanted to, for this one here, we could have gone and said that x cancels out with that x. This 3 and this 9 simplifies the 9 to 3. because 3 over 9 would simplify to 1/3. 6 and 3 do have a common factor of 3. Well, that would simplify to 1. This would be 2. This 2 and this 8 would simplify to 4. And we could do it that way. But if, and it's all in how you see it and kind of keep track of it in your head. If this here, what I just did, is a little much, that's fine. You don't have to do it that way at all, because what we just did will get us to the correct answer still. Any questions on this here? We're going to be looking at this one here. Multiplying with polynomial expressions in these rational functions. And whenever we multiply with more than one term, it's going to be best to factor first. It's going to be best to factor these first before we start multiplying together. And out of all these here, the easiest one that we have is 3x, because it doesn't factor. It's as simplified as it gets. Now, the one I would look at next is the 3x minus 3x squared. Because there is a greatest common factor between 3x and 3x squared, which would be 3x. Because 3x isn't common in both terms. Then as we factor the 3x out, when I factor a 3x out of 3x, I'm left with 1. Because whenever something factors out completely, it simplifies to 1. Minus, when we factor a 3x out of 3x squared, we're left with x. So since it is x squared and I removed 1 from it, we'll just be left with x. Now the question becomes, do we want to factor the x squared plus x minus 20 first? Or the x squared plus 4x minus 5 first? So we'll look at x squared plus 4x minus 5. Since the third term is negative, our signs are going to be opposite. Now the factors of x squared are x and x, because that's the only set of factors for x squared. The only factors for 5 are 1 and 5. Now we need to decide which one we want positive and which one we want negative. And the 5 would be positive. And if we did check it and multiply to find the middle term, we would see this setup would give us a positive 4x. And lastly, we can factor the other one. Since the 20 is negative, our signs are going to be opposite. The factors of x squared are x and x. Now, most likely, we're hoping that one of these two sets of parentheses is either going to be x plus 5 or is going to be x minus 1. And we look at the factors of 20. Yes, I would stick with 4 and 5. And we would want the 5 to be positive and the 4 to be negative. And if we did check this, this would give us a positive x for the middle term. Now at this point here, we do have everything factored, so we can go on and multiply them together. If we do have any individual terms, I like to move them up front. So the 3x, I would put it in front, so it's not kind of lost in the middle. Then we have our 1 minus x, our x plus 5, and our x minus 4, all over 3x times x plus 5 times x minus 1. Do we have anything in common on top and bottom? Yes, we have a few things. One of them is what? The 3x and 3x are in common. X plus 5 and x plus 5. we do have an x minus 1 on bottom, and on top we have a what? 1 minus x. And we can actually get those to cancel. We just have to do something first. Well, apparently it's going to do that. And we have 1 minus x times x minus 4 on top. And on bottom we have x minus 1, yes? So they are almost the exact same, except for the signs are what? Flipped, yes? And we can do this if both signs are flipped. And what we can do is we can factor out a negative 1. Because if we factor a negative 1 out of the 1 minus x, if I factor a negative out from the negative x, the x is going to go from negative to positive. So it'll be a positive x. And the positive 1 is going to go from being positive to being well, now we can cancel those out. And it's actually just going to leave us with a negative x minus 4. And that's it for that one there. Any questions on any of this here?